Okay, we're going to take a look at this excellence question. The biggest problem with this excellence question is trying to figure out what this is getting you to do. And basically, you have to understand that you're going to be creating a box, if you will, that has length times width times height, basically. And you have to understand that you're going to have 3 dimensions, obviously, and what those dimensions are going to be. So you basically got this part here, which is actually when you fold, that becomes like one of the dimensions. That becomes, well, you could think of it as this side here, if you will. And so that's x, because the dimension of this, we don't know. We don't know what that bend fold line is, and we don't know what this bend fold distance is. This is going to be x, and this is going to be x, right? So basically we've got dimensions, which is this side here, but we've got to take off these fold lines. So it's 110 minus 2x, and that becomes one of these dimensions. It doesn't matter which one you want to call that. You can call this the bottom if you want to be 110 minus 2x, so that's one of the dimensions. The other dimension is the 220, and we've got this fold and this fold, right? So basically it's going to be 220 minus 2x, which will reduce to 110 minus x. So that's another dimension. And it doesn't matter which side you want to call these. So this is one side, this is the other side, and then you've got sort of the height of this, which is going to be basically just when you fold, this thing is going to be, this other dimension is just basically going to be this. So it's x. Now, coming up with that is paramount to being able to do this question, obviously. If you can't come up with the dimensions of this box being basically (110 minus the 2x, 110 minus x, and x, length times width times the height. Well, that's probably x there. That's probably the other one, because it's not very wide. I mean, that's this, right? So now we've got volume is equal to 110 minus 2x times 110 minus x times the height or width or whatever you want to call, which is x. And then obviously you're going to have to expand this out. And when you expand this out, you get 2x cubed minus 330 x squared plus 12100x. Okay? So that's the volume expression, and you must do that. So you have to find maximum volume. So the first thing you have to do is write an expression for volume, and then you're going to know that because it's maximum, you're going to be differentiating that. So that's the first step, find volume. Second step, differentiate the volume, right? So when we differentiate this, we get 6x squared minus 660x. 12100. Now, at this point, you have to show 6x squared minus 660x plus 12100 is equal to 0. Now, we talked about the fact that you could then factor this thing out by hand to find what your x values are going to be. But I wouldn't want to do this by hand, and you don't need to do it by hand. Once you've made this statement, you can throw it into your calculator and you can get your x values. And your x values are 23.25 and 86.75. Now, the original expression is a cubic, and it's a positive cubic. So the function looks like this, where this becomes, the first point is your max, and the second point is your min. So you should know that off the bat, and draw that so that they understand that you know what you're talking about with regards to which one's positive and which one's the maximum and which one's the minimum. So at this point, the maximum volume occurs at the earliest 23.25 based on the fact that it's a positive cubic. Now, you may want to find the nature of that root by double differentiating. Turning point. Depends on how much time you have, just to be sure. Or you could sort of draw this sketch and show that since it's a positive cubic, it would be sufficient in this context of this question to stop there and say that the 23.25 is going to be the maximum point. Now, you don't need the y value for this because all we need is the x value. And then all you're going to do is stick that x value into your original equation. And when you do that, when you stick that into the original equation, which is volume is equal to 2 times 23.25 cubed minus 330 times 23.25 squared plus 12100 times 23.25. And you work it out, and you're going to get 128076 cubic centimeters as your maximum value.